All right, for the exponent rules. There's some exponent rules that are kind of like simple and short, and what we want to be able to do is do those both with numbers, but also with just variables, okay? So let's start with here. So like here, n to the third to the fourth power. Like I really want to take this and be able to not necessarily have it memorized all the time, but just be able to look and think, okay, what does this mean? And what it means is that I have n to the third 4 times. So like if I have this 4 times, and this feels really wasteful to write it out because I can picture this in my head. How many n's do I have? Well, I have 3 n's 4 times, and that's n to the 12th. And then I want to observe. I want to say to myself, oh, what did I do with these two numbers? Well, I multiplied them. I have 3 n's 4 times. So what I did is I multiplied them. So if they were just both letters, I could still write this. I would say, oh, you know what? This is x to the a times b, right? Whatever those two numbers are, they're going to end up being multiplied. How about in this situation? This is n to the fifth, 1, 2, 3, 4, 5, times n to the third, 1, 2, 3. And again, this is something that I'm hoping you get to the point where you don't write it out like this, you picture it in your head. But what I can see here is that there are 8 n's, and I can ask myself, okay, what happened here? Well, what happened is there was 5 n's and there was 3 more n's, and so there ended up being a total of 8. And what did I do with these numbers? I added them. So if I have a situation like this would be x to the a plus b. Okay, now, again, I'm not encouraging you to memorize these rules. Oh, this is always multiplying, this is always adding. I'm encouraging you to always be able to just kind of write this out in your head and say, oh yeah, I remember that, right? This is adding, okay? Anything to the 0 power is 1. So it doesn't matter what variable, it doesn't matter what number, anything to the 0 power is 1. If I have n to the negative 7, that means, oh, this is just so unhappy. It's just, oh, miserable. And there's an invisible fraction right here, and it just really doesn't like to be on this side of the fraction. It really prefers to be on the other side of the fraction. So this would be n to the 1 over n to the 7th, and look how happy that n is now that it's on the bottom of the fraction. And the same thing would happen here if this exponent was a variable. Instead, this would be x to the power of a. Okay, what happens here? What did we learn about fractional exponents? Well, we learned to rewrite them when we said, oh, this was the index, right? That's this number. And this number up here was the exponent. Remember, it was always exponent over index. So that would look like this. And again, if it's variables, that's just the same. This is the index, and this is the exponent. Okay, so notice what we're doing. We're kind of just realizing that these variables just represent numbers, and they behave exactly the same way that numbers do. Okay, so here, this is n to the 9th over n to the 4th, and this is one that we've really struggled with a little bit, but this is one I'm going to write out so we can really see 1, 2, 3, 4, 5, 6, 7, 8, 9 over n to the 4th, looks like this, and then I say, oh, this is a fraction. Well, this is n divided by n, that's just 1. This is n divided by n, that's 1. This is n divided by n. Whoa, what do I have left? I have n to the 5th left. So what happened here? Well, I had 9 n's, and 4 of them got canceled because they were, as part of a fraction that got simplified. So what I ended up doing is that having 9 n's and taking away 4, I ended up subtracting. So in this situation, this would be x to the power of whatever this top number is minus whatever the bottom number is. Okay, and then last one, n to the power of 1 is just n, and x to the power of 1 is just x. Okay, and we can take these again, we can take these rules that we can just sort of observe, and we can make them these rules that sort of work for anything. All right, convert to exponent form. Remember that this is called the index right here, and this is called the exponent right here. And I didn't leave myself enough room, and so if I write that in exponent form, I just write it like this. The exponent goes over the index in the fraction. So here I'm going to write, this is x to the exponent over index, that's 7 over 5. Here, this is n to the power of, oh, and look, this is 8, and oh, there's no index. What is it? If there's no index written, it's a 2, right? This is the square root. This is 8 over 2, and oh, I can simplify this. 8 divided by 2 is 4. Okay, so make sure you simplify if you can. All right, this one, there's no exponent written. What is it? Oh, it's a 1, right? It's invisible 1 if it's not written. This is 1 over 3. And here there is no exponent written. That's a 1. And there's no index written. That's a 2. And so when I write my fraction, it's exponent over index. And that's a 2. And I need to sharpen my pencil. Okay, let's take a look at the radical form. We're just going to go the other way. So here I'm going to write a. And I'm going to write the exponent. Oh, I don't write a 1. I look silly when I write it. And I also don't write a 2. So this is just the square root of a. Here, I'm going to write my exponent over my index. Okay, here I go to write my exponent, it's a 1, I don't write it, but my index is a 5. And then lastly, I write my exponent of 7 and I don't write my index of 2. So just like this. Okay, so now on this problem, and in fact, there's not a problem just like this on the test, but if you can do this problem and you can do all the steps, there's nothing on the test that you don't know how to do. So let's get started. The first thing I'm gonna do, the only thing I'm gonna do in this first step is just move negative exponents. So notice nothing is moving, nothing, except this. So this, look, there's a B down here. See, that's this B. Okay, now there's more B's, that's these from up top. Okay, so notice I didn't lose track of this B, okay, careful, don't lose track of that one. Okay, so the first thing I did, I just moved negative exponents. Okay, that's the only thing I did here. The only thing I did is move this term down here. Okay, now the next thing I'm gonna do is I'm gonna simplify the A's and the B's. Okay, now look, I'm gonna choose to write it out the long way. And a lot of you are at the point where you're like, oh, I don't need to do this anymore. That's totally fine, love that for you. But I'm gonna just write it out just for those of you that are still a little bit like, wait, what do you mean simplify? Let's see what I mean. Okay, look what I did. I wrote 4 A's on the top and 6 A's on the bottom. There's no B's on the top, right? There's no B's, but there's this B on the bottom, and then there's 5 more B's. 1, 2, 3, 4, 5. Okay, so now what's gonna happen here? Oh, okay, what's left on the A's? Well, the only thing left on the A's, there's no A's left on top. Okay, and the only A's left on the bottom are just these 2. And I'm gonna just bring the 5 and the 3 down. So there's 2 A's on the bottom. Okay, and then what's left for the B's? Okay, the B's, look, there's a B, and then there's 5 more B's. 1, and then 1, 2, 3, 4, 5. So that's a total of 6 B's. Okay, so what did I do here? Okay, what I did is I simplified, like I combined each variable. And I treated them very much separately, right? Something different happened to the A's. The A's, like I was like, oh, I have some on top and I have some on the bottom, and I canceled, right? Like I simplified them in the way that I simplified like this one, right? Whereas the B's, I simplified, oh, I had a B and then it was next to some more B's. And so that simplified more like these. And so I'm not saying exactly what's happening to each variable, right? And I don't want you to think, oh, what I always do is I subtract the A's and I add the B's. No, don't memorize that. Just be able to picture this in your head, okay? And now I'm ready to take it to the third power. Why? Because everything inside here is as simple as I can possibly make it. So now 5 to the third power is 5 times 5 times 5, that's 125, and that's the only thing on the top of my fraction. 3 to the third power is 3 times 3 times 3, that's 27. And then this is a squared to the third power, so that's a times a, 3 times. So that's a times a times a times a times a times a, that's a to the 6th. And this is 6 B's, like imagine 6 B's written out 3 times. So that's 6 B's 3 times, that's 6 times 3, that's 18. Okay, and if you can do each of these steps, right? You can do each of these steps first, move any negative exponents, then simplify what's inside and simplify each variable, and then take it to the power. If you can do these 3 steps, you can do any of the questions that are on the test.